We have another example on the board. I would start solving this problem from finding I total or IR, IC. You have to realize that anytime I say current which goes through the resistor or current which goes through the capacitor or I total, I'm talking about the same current. Why? Because this is series circuit. So that's why I'm going to find IR first. Why? Because I have two pieces of information across the resistor. I have resistance and I have power at the resistor. So I have formula which says that true power is equal IR square times the resistance. If you are going to rearrange the formula, you're supposed to get IR is equal square root power over resistance. This is equal IR, which is equal to current which goes through the capacitor, and this is also equal I total is equal square root open parenthesis P 40 watts over resistance, which is equal 1 kilo. This is equal 200 milliamps. But this answer is not full. I mean, it's not complete because we are missing the angle. But we are going to find the angle soon. Next, what I'm going to do, I'm going to find Z total. Why? Because I have voltage source and I have current. Z total is equal voltage source over I total, where voltage source is equal 500 volts and I total is equal 200 milliamps. So voltage source over the current total is equal 2.5 kilohms. But again, we have no angle. So what we're supposed to do next? You're supposed to remember the formula for the power factor. Power factor is equal cosine theta, and this is equal resistance over Z total. So from this formula I can find angle theta. Theta is equal inverse cosine R over Z total. And this is equal inverse cosine R, which is given 1 kilo, over Z total, which we found is 2.5 kilohms. This is equal negative 66.42 degrees. Again, someone is going to ask, how come you got negative? Please notice that we are dealing with RC circuit. The total impedance, right, of the RC circuit is going to go with negative angle. So the complete answer for Z total is 2.5 kiloohms, an angle of negative 66.42 degrees. This is my Z total. If I want to find I total, so simply write I total is equal to voltage source over Z total. We have found already the magnitude of the total current, so I don't suppose to rewrite them one more time. I just look at the angles. So if the angle of voltage source is not given, I assume that this is 0. And Z total has angle of negative 66.42 degrees. So my I total, okay, is equal to 200 milliamps. And if you are going to subtract these two angles, you are going to obtain 66.42 degrees. And this is my current, which will go through the resistor and capacitor. So next we're supposed to find X of C. This is series circuit. So Z total for series circuit is R plus X of C. In order to find X of C, we're supposed to move R to the other side, and we are going to obtain the formula X of C equals Z total minus R, where Z total is 2.5 kiloohms and angle of negative 66.42 degrees minus R, which is equal 1 kilo. So X of C is equal 2.29 kiloohms and angle of negative 90 degrees. Okay, so this is the value of X of C. Next, we're supposed to find voltage drop across the resistor. In order to do so, I'm going to use Ohm's law. VR is equal IR times resistance, where current is equal 200 milliamps and angle of 66.42 degrees times the resistance, which is equal 1 kilo. This is equal 200 volts and angle of 66.42 degrees. This is the voltage drop across the resistor. If you want to find voltage across the capacitor, this is IC times X of C. So I have 200 milliamps an angle of 66.42 degrees times X of C, which is equal 2.29 kiloohms, and angle of negative 90 degrees. This is equal 458 volts and angle of negative 23.58 degrees. This is the voltage drop across the capacitor. And someone is going to say, okay, I can continue and try to find the next thing. It's okay, but it's always good to check if your answers are correct. I always recommend to check if the values which we obtain are correct. So I have VR plus VC. I'm supposed to use KVL because KVL says that the sum of the voltages in the series circuit is equal to the voltage source. So that's why I'm going to have 200 volts and angle of 66.42 degrees plus 458 volts and angle of negative 23.58 degrees. If you are going to add these two values, you're supposed to obtain 500 volts and angle of 0.009 degrees, which I consider as the 0 degrees. Okay, so we can say that these two values are correct. In order to find the capacitance of the capacitor, I'm going to use the formula for capacitive reactance. X of C is equal 1 over 2 pi Fc. Use algebra to solve this formula for C. C is equal 1 divided by, open parenthesis, 2 pi F times X of C equals 1 divided by, open parenthesis, 2 pi times F 640 Hertz times X of C, which is equal 2.29 coulombs. And you're supposed to get the value of 108.59 nanofarads. Okay, so this is the capacitance of my capacitor. Next, I'm supposed to find the power factor. Power factor is equal cosine theta. So I have cosine of angle negative 66.42 degrees. This is equal 0.4. And you're supposed to add word lead. Why lead? Because your angle theta is negative, or because this is RC circuit. RC circuit is going to have always negative angle next to Z total. Okay, so this is power factor. Next, we're supposed to find the reactive power. So QC is equal IC square times X of C, which is equal 200 milliamps raised to the second power times X of C, which is equal 2.29 coulombs. So your reactive power has to be equal 91.6 VAR. And if you want to find apparent power, S is equal I total square times Z total, which is equal 200 milliamps to the second power times Z total 2.5 coulombs, which is equal 100 VA, volt ampere. Okay, if you want to draw the power triangle, you're supposed to simply draw the true power. P is equal 40 watts. QC is equal 91.6. I'm going to make this a little bit longer. So this is QC equals 91.6 VAR. And this is my apparent power. S equals 100 volt amp. And this is my angle theta. Please keep in mind that this angle theta is the angle theta which we have next to Z total. So we can say that the problem is solved.